Jai Hind everyone. I am Anupam Kumar Saini, Assistant Professor, IT Department, AKGEC, Ghaziabad. Today I am going to discuss the topic function. This is the from second year. This is important topic for the student of second year CS, IT and allied branches of CSE. So what is function? Function is a given any set AB, a function f from A to B, or it's also known as mapping from A to B. We can represent it function can written as f such that A implies B is an assignment of exactly one element, that is fx belongs to B. To each element x belongs to A. In function there are two sets A and B, and it shows the mapping between these two sets. And if we write it f colon A implies B, then image of A is B. Function can be represented graphically in various ways. One of them is like Venn diagram. Here two sets are there, A and B, two sets, and element of A is A and element of B is B, and the function represent A to B, means mapping of A is B. And in graphical method there are two sets A and B, and these are the elements of A and these are the elements of B, and we can plot a graph of two sets x and y axis, and this is also known represent the function, the two variables x variable and y. So formal definition of function: x is a function and is represented as f such that A implies B. X is a function if for some x y where x equal to y and fx not equal to fy, means all the elements of x and all the elements of y. Second one, x is a function for all x y. This symbol represents negation, x equal to y, or negation of fx not equal to fy, or other way, x is a function for all x y, negation of x equal to y, or fx equal to fy, or x is a function for all x y, x equal to y, then fx equal to fy, or x is a function for all x y, fx not equal to xy, then x not equal to y. These are the some definition of function. So basically the terminology used here, if f is a function and a implies b and f a equal to b, where a belongs to a and b belongs to b, means a is the element of set a and b is the element of set b, then a is a domain of f, then a is a domain of f. Element of a is known as domain of the function f, and b is the means element of b is the codomain of f. Then b is the image of a under f. So if write it here, f a equal to b, then b is a image of a and a is the pre-image of b. If f a equal to b, then b is the image of a and a is the pre-image of b. In general, b may have more than one pre-image. The range R is the subset of B of F is B for some A, F A equal to B. So here say that the range of the, when we find the range, then the range belongs to element of set B and the range is the subset of B. Means all the elements should belongs to B, maybe range of the function. We can add and multiply functions f plus g. Here two functions are used, f and g, and we add the function f and g of x, fx plus gx this way, and multiplication of two function f into g, where f into g x fx equal to gx. For function we use the symbol O. So g is a function for a to b and f is a function for b to c. We consider two functions here. First function is g for a to b and second one is function is f for b to c. For function there is a special operator called compose or composition operator, and this is represented by O. It composes a new function out of f by applying f to the result of g. When we find the function f and g composition, means composition of f and g, and the relation given here a implies b for g and f for f, b implies c. If we find the composition of f of g, then it gives the result, the relation A to C. In G, relation is given from function A to B, and in function F, the relation is B to C. When we find out the composition of function f and f of G, this gives the result of A to C, where f of G of A is written as f of G of A is equal to, first we have to find out the value of GA. After that, we put this value on function f. Then we have to find out the value of f GA. If we find out the value of f of G of A, f of G of A, so we have to first solve it G of A, then the given result put on the f for the function f, then find out the result. So for this way we find out the composition of function. Note, GA belongs to B, so FGA is defined and belongs to C. As discussed here, f of G is the relation from A to C. Means if there are two functions, two sets A, B, and one set is C, this represents the function f and this represents the function G. If we find the composition of f of G, then we get f of G is the relation of A to C. The range of G must be a subset of F's domain. That composition, like Cartesian product, unlike and union, is non-commuting. In general, f of G not equal to G of f. F of G not equal to G of f. If we find the composition of f of G and composition of G of f, it will not equal to so function composition is represented here. This is G, set, this is set A, whose element is represented here A, and this is a relation B whose element is GA, because this relation is GA, and f of GA is C. So here if we simply say that this is f, this is G, and we find out this one is the relation of f of G, f of G. So image of sets under function given f is a function for A to B and S is a subset of A. The image of S under F is simply the set of all images under F of the element of S. Fs logically equivalent to Fs for S belongs to S and B for some S belongs to S and Fs equal to B. This is also read as existential function symbol. Note the range of F can be defined as simple the image under F of F's domain. There are various types of function. First one is one-to-one function. A function is one-to-one or injective or an injection if every element of its range has only one pre-image. Only one pre-image. So I explained with diagram also. Only one element of the domain is mapped to any given one element of the range. Domain and range have same cardinality. Cardinality means number of elements is known as the cardinality. Number of element belongs to domain. When we find out the domain and range, so number of element, counting the number of element is known as the cardinality of the that domain. So graph representation of function that are, this is a set A and B. If all the element of A and B have only single means one pre-image of every element, there if we assign the name 1, 2, 3, 4, A, B, C, D and E, then B is the image of F1, function of 1's image is B, A is a image of 2 and C is a image of 3 and E is a image of 4. Here only one image, so it is known as 1 to 1. So this is 1 to 1. Here more than 1 means this is a image of 2 elements and here one more than 2. So this is not 1 to 1, not even function. This is not in function. Many to 1, many to 1 is allowed for function, but 1 to many, 1 to many is not a function. So it in this diagram of A and B sets. This is not a function, even not a function. This is a function but not one to one. This one is a function but not one to one function, and this diagram not a function, not a one. If it is not a function, then we not need to find out the one to one function or not. This is not a function. Only in these three diagram, this one is the one to one function, because all the elements have single image. These are the some condition of one to one definition for function f over numbers. F is a strictly or monotonically increasing. If x is greater than y, then fx greater than y for all xy in domain, and f is strictly monotonically if decreasing x greater than y, then fx is less than fy for all xy in domain. And if f is either strictly increasing or strictly decreasing, then f is 1 to 1. For example, fx equal to x cube. Second function is onto function. Onto function, b is a onto or surjective or surjection if its range equal to its codomain. Means if the all element of B belongs to range. So for all B belongs to B, for A belongs to A, FA equal to B. And onto function maps the set A onto over covering the entirely of the set B, not just over a piece of it. For example, for domain and codomain are, for x cube is onto, whereas x square is not. Why explain in with the diagram in next. Some functions that are not onto their codomain. Here see the diagram. This is the A, B, this one set A and B. If we name it 1, 2, 3, 4, 5, A, B, C, D, all similar. A 1, 2, 3, 4, 5, A 1, A, B, C, D, and A, B, B, A. So for this way, this is the two set A and B. This represent the relation function onto but not one to one. This function is onto because all the elements are the image of A. All the elements of B, set B, is the image of A. So this is onto. This function, in this function is A, B, C, D. C is not image of any element, means if find out the codomain and range of this, then range of this will be A, B and D, and codomain will be A, B, C, D. So codomain and domain are not equal. So this is not a onto function, because codomain and range are not same. In according to definition, onto function, codomain and range should be equal. In third one, this is 1 to 1 and all have the image of A, then it is also onto and 1 to 1 also. This one is onto because all the elements have the image of set A, and in this all the elements are image of A, then this is also onto. No, because one yes, this is the diagram. This element is not the image of any element of A. This means A is not the image of E of A is not the image of any element of A. So this is not a onto. And the bijective, a function f is 1 to 1 correspondence or bijective or reversible or invertible if it is both 1 to 1 and onto. If this is both 1 to 1 and onto. Okay, thank you. I will discuss the topic in next class. I will discuss remaining topic in next class. Continue in next class.